let me give you this scenario here. Let's say if I were to offer you option one to throw one die, but you must get a 6 with this one die, or option two, you throwing two dice, but you have to get a double. So, for example, a 3 and a 3, that's good. A 4 and a 2, no good, because these two are not the same. You have to get a double. So, which is easier to do? Is it throwing one die and getting a 6, or throwing two dice and you must get a double? Which is easier to do? You see, to answer this question, you really have to use probability here. So with probability, you always try and find out, you always try and draw a map of all the possible things that could happen. So if you look at the option one here with one die, well, one die you can get a 1, you can get a 2, you can get a 3, you can get a 4, you can get a 5, or you can get a 6. Well, the probability, the probability of you getting a 6 would be P of 6 equals 1 out of 6. Okay, so yeah, because again, you want to visualize all the things that could happen with this scenario here. So there are 6 possible things, and there's only one thing that you're interested in, which is the 6. Okay, so the probability of you getting a 6 would be 1 over 6. Now look at option 2 here. Option 2, well, again, you want to somehow find out all the possible routes, and one way of doing that is to draw a table like what we've done in the past. So it's 1, 2, 3, 4, 5, 6, and then you have 1, 2, 3, 4, 4, 5, 6. So this could represent our first die here. Okay, so this could represent our first die, and this here represents our second die. Okay, second die. So here, hang on, bear with me. So we are trying to draw a map of all the things that could happen. Hang on, you will see. It will make sense later on. Now, if you want to get a double, then this is a good outcome, because a 1 and a 1, that's a good thing. A 2 and a 2, that's a good outcome. A 3 and a 3, that's a good outcome. A 4 and a 4, that's a good outcome. A 5 and a 5, that's a good outcome. And a 6 and a 6, that's a good outcome. So 1, 2, 3, 4, 5, 6. So the probability of getting a double equals, well, 6. Well, don't forget that there are 6 times 6. There are 36 possible outcomes with two dice, and out of the 36, there are 6 that gives us what we want, which is getting a double. So it will be this, okay? And it turns out that this is the same as this, because if you get a calculator and convert 1 over 6, hang on, let me get a calculator out. Calculator. If you convert 1 over 6 to a decimal, 1 divided by 6 equals 0.17, 0.17. Okay, and if you get 6 divided by 36, clear, 6 divided by 36, that also equals 0.17. Well, remember, when you have a fraction, you can divide top and bottom by the same thing. You could divide top and bottom by 6. So 6 divided by 6 is 1, and 36 divided by 6 is, well, basically, what I'm trying to say is this is the same as this. So going back to our, hang on, let me just summarize. The probability of us getting a 6 is 1 over 6. The probability of us getting a double is 6 out of 36, and it turns out that these two are actually the same. So, which means, well, the probability of you winning with option 1 is 1 out of 6. The probability of you getting a double with two dice will be 6 out of 36, which equals 1 over 6. these two are the same. So it turns out that it doesn't matter. The probability would be the same. It doesn't matter if you take this option or this option. They're both the same. Okay?